Welcome to our channel. Today we're diving into the top 10 unsolved mysteries in science that continue to baffle researchers and scientists around the world. From the vast cosmic unknowns of dark matter and dark energy, to the perplexing puzzles found right here on Earth, we'll journey to the very edge of human understanding. So fasten your seatbelts, engage your curiosity, and prepare to be amazed as we explore the top 10 unsolved mysteries in science. Out there beyond the familiar glow of stars and galaxies, lies a profound mystery, dark matter. Imagine an invisible form of matter, unseen by our telescopes, yet exerting a powerful gravitational pull on everything we observe. We can't see it, can't touch it, but we know it's there by its undeniable influence on the rotation of galaxies and the way light bends around massive objects. Current estimates suggest that dark matter accounts for a staggering 85% of the universe's total mass. The dazzling stars, the swirling nebulae, the planets, and even ourselves, all of it, represents a mere fraction of what's actually out there. This leads us to a fundamental question. What is this elusive substance? Is it composed of exotic particles yet to be discovered, or does it hint at a fundamental gap in our understanding of gravity? For now, dark matter remains a tantalizing enigma, a cosmic shadow reminding us of the vastness of the unknown. The universe is not just expanding, it's accelerating. Imagine a loaf of raisin bread baking in the oven. As the bread rises, the raisins within it move farther apart. But what if instead of simply expanding at a constant rate, the bread started to rise faster and faster? That's the puzzling phenomenon of cosmic acceleration. Driving this acceleration is an even more mysterious force than dark matter, dark energy. Unlike dark matter, which exerts a gravitational pull, dark energy acts as a kind of anti-gravity, pushing everything in the universe apart at an ever-increasing rate. We don't know what dark energy is, but we can see its effects. It's like an invisible hand on the cosmic accelerator, pushing galaxies away from each other with increasing speed. Will the universe continue to expand forever, growing colder and darker as galaxies are pushed farther and farther apart? Or will this expansion eventually slow down, perhaps even reversing itself in a cosmic big crunch? The quest to understand dark energy is one of the greatest challenges facing modern cosmology. Our universe exists in a delicate balance, a cosmic dance between matter and antimatter. For every particle of matter there exists an antiparticle with the same mass but opposite charge. When matter and antimatter meet, they annihilate each other in a burst of pure energy. Here's the mystery: if the universe began with a perfectly balanced Big Bang, with equal amounts of matter and antimatter, then everything should have annihilated, leaving behind nothing but a sea of energy. Yet here we are, surrounded by a universe teeming with matter. This begs the question, where did all the antimatter go? Why is there this Baryon asymmetry, this imbalance favoring matter over antimatter? Physicists believe that this asymmetry must have arisen in the universe's earliest moments, during the chaotic aftermath of the Big Bang. They suspect that subtle differences in the behavior of matter and antimatter, perhaps governed by new laws of physics, tipped the scales in favor of matter. Unraveling this mystery is crucial for understanding the very fabric of our existence. In the annals of space exploration, few missions have been as audacious as the Pioneer 10 and 11 probes. Launched in the early 1970s, these robotic explorers were the first to venture beyond the asteroid belt, beaming back stunning images of Jupiter and Saturn before continuing their journey into the vast unknown. But as they sailed farther from the sun, something strange happened. Both spacecraft began to deviate slightly from their predicted trajectories, as if some unknown force was gently tugging at them. This became known as the Pioneer Anomaly. Was it an unanticipated effect of solar radiation pressure? Was it a subtle gravitational influence from unseen objects in the outer solar system? Or could it be something even more exotic, a hint of new physics beyond our current understanding? Despite decades of analysis and speculation, the Pioneer Anomaly remains unexplained. Beyond the orbit of Neptune, in the frigid outskirts of our solar system, lies a vast and mysterious realm, the Kuiper Belt. This ring of icy bodies, remnants from the solar system's formation, is home to dwarf planets like Pluto and countless other icy objects. But as astronomers studied the distribution of objects in the Kuiper Belt, they stumbled upon a perplexing puzzle: the Kuiper Cliff. At a distance of about 50 astronomical units from the Sun, the number of Kuiper Belt objects drops off dramatically, as if someone had taken a cosmic broom and swept the region clean. What caused this abrupt drop-off in icy objects? Was it a gravitational disturbance from a rogue planet lurking in the outer solar system? Some scientists have proposed the existence of a hypothetical planet, often called Planet 9, to explain the Kuiper Cliff. The search for Planet 9, if it exists, is one of the most exciting frontiers in planetary science. In the summer of 1977, a radio telescope at Ohio State University picked up a signal so remarkable, so strikingly artificial in its appearance, that astronomer Jerry Amon scribbled "Wow" on the printout. The "Wow" signal, as it came to be known, was a powerful burst of radio waves lasting 72 seconds, originating from the constellation Sagittarius. Its narrow bandwidth and steady frequency suggested a non-natural origin, potentially an intentional transmission from an alien civilization. Despite decades of follow-up observations and analysis, the "Wow" signal has never been detected again. Was it a stray signal from Earth-based technology reflected back from space debris? Was it a natural phenomenon that we simply don't yet understand? Or could it have been a fleeting message from a distant world? The human mind is a powerful thing, capable of influencing our physical well-being in ways we are only beginning to understand. One of the most perplexing examples of this mind-body connection is the placebo effect. Imagine a patient suffering from a chronic illness. They enroll in a clinical trial and are given a sugar pill, an inert substance with no known therapeutic value. Yet, to their surprise, their symptoms improve. This isn't merely anecdotal evidence. The placebo effect has been observed in countless clinical trials across a wide range of conditions. But how can a sugar pill, devoid of any active ingredients, have such a profound impact on our health? The answer lies in the complex interplay between our expectations, beliefs, and the brain's intricate network of reward and pain pathways. When we believe that a treatment will work, our brains release endorphins and other neurochemicals that can mimic the effects of real medication. This doesn't mean that the placebo effect is all in our heads. It's a very real physiological response triggered by our thoughts and expectations. Sometimes the simplest observations can lead to the most perplexing questions. Take, for example, the act of placing a container of water in the freezer. Common sense tells us that the hotter the water, the longer it will take to freeze. Yet there are times when hot water seems to defy this logic, freezing faster than cold water. This counterintuitive phenomenon is known as the Mpemba Effect. Named after Erasto Mpemba, a Tanzanian student who observed this effect while making ice cream in the 1960s, the Mpemba Effect has puzzled scientists for decades. Numerous explanations have been proposed, ranging from differences in convection currents to the influence of dissolved gases. Some scientists believe that the effect may be related to the unusual properties of hydrogen bonds, the weak forces that link water molecules together. Despite numerous studies and experiments, a definitive explanation for the Mpemba effect remains elusive. From the smallest single-celled organisms to the complex ecosystems that blanket our planet, life is a symphony of breathtaking diversity and complexity. Yet the question of how life arose from non-living matter remains one of the most profound mysteries in science. Imagine the early Earth, billions of years ago, a harsh and unforgiving environment bombarded by radiation and volcanic activity. Somehow, amidst this chaos, the building blocks of life organic molecules like amino acids and nucleotides emerged and assembled themselves into the first self-replicating systems. Was it a chance event, a lucky strike in the primordial soup? Or were there underlying chemical and physical laws that favored the emergence of life? The universe is vast, teeming with billions of stars and planets. So, where is everyone? This is the Fermi paradox, posed by physicist Enrico Fermi in 1950. It highlights the contradiction between the high probability of extraterrestrial life and the lack of evidence. Are we alone, or are alien civilizations hiding? The Fermi paradox remains a thought-provoking puzzle. Thanks for watching. If you enjoyed this video, don't forget to like, share, and subscribe for more fascinating content. Let us know in the comments which mystery you find the most intriguing. These 10 unsolved mysteries represent just a glimpse into the vast unknown that surrounds us. As we continue to explore the universe and probe the mysteries of our own existence, we are reminded that the journey of scientific discovery is never truly over.